And we're on. Hello.
Hi.
So we've got Tom Eccles here. Tom is my friend from Codethink, and we haven't talked in a while. I think last time we talked was when I was in Manchester in July or August, um, just after I left Codethink. So how have you been?
Yeah, I've been good. It's been, well, uneventful. I can't really go outside and do anything, but yeah, I'm settling into a new flat in Manchester. So that's all quite exciting. And it's been nice because I've been able to stay in and really work on the flat and be here. Whereas normally I'd be always off out to work or whatever.
That's pretty cool. How's work going in general? All good?
Yeah, it's good. I've been working on various open source stuff, which is always good. I always like doing that. So over the summer I was working with some Rust, upstreaming some things, and then recently I've been doing a internal project that we're hoping to open source soon.
Open to open source what?
It's an open source logic analyzer.
Oh, is that the thing that they've been posting about, the medical thing? I
No,
don't know.
that's a it's sort of like that's a smartwatch sort of thing, but it isn't a smartwatch form factor the one they've built, but it's intended for smartwatches. So you have that's LEDs shining into your skin, whereas the logic analyzer, it's for taking samples of digital signals quickly.
Okay, that's pretty cool. When I originally invited you to be on the show, I wanted to talk about your work with. You had a blog post about the Rust compiler internals on the Codethink blog that kind of went viral, semi-viral on Reddit. So can you talk a little bit about that?
Yeah. So we're looking for internal projects to do over the summer, and one idea we came to was we wanted to make sure that Rust support was good for RISC-V Linux. So the way it comes down to most Linux distributions, because I've had just before the start of the project, the start of the summer, we had Ubuntu 2004 coming out with RISC-V support. There's a few others. So we wanted Rust to then be usable on those platforms, in case anyone actually manages to find some hardware. And so we had a look, and there was already a target in Rust compiler for RISC-V 64-bit Linux, but it wasn't at all officially supported. There was no official builds or anything. It wasn't tested at all. It was just there to figure out, and there wasn't anything in the wider ecosystem. So my job was to sit down and make it easy to use.
Okay, so for people who are not familiar with Rust is a fairly new programming language that's kind of supposed to be on the same level as C, C++, but memory safe, right?
Yeah.
That's like one of the main features.
And it's not doing memory safety the way it would be traditionally done. So a lot of languages, say Java would claim some degree of memory safety, but it would get there by having a great big runtime.
Yeah.
Whereas Rust, like you said, it's on the level of C or C++, so it's all in a very fussy compiler, which I like. Some people don't like, but it's really cool because then you know that when the code compiles, it has these properties, as long as you're using safe Rust.
Yeah, it's like Rob Kendrick said that you have to spend like 10 hours dealing with the compilation errors, and then once it compiles, it just works.
Most of the time, yeah.
Most of the time. Yeah, I mean, obviously, like it's not going to take away all, like some people have this like dream that one day we're going to just be able to program everything very easily and it's just going to work without any bugs. I don't really think that's going to happen soon, but at least it eliminates this huge class of errors.
Oh yeah, oh yeah. I mean, there's a lot of bugs that, like the bugs I was ended up fixing in Rust compiler. But it's not something that you could ever catch with some sort of like type system or static analysis, because it's bugs in get it in what you think you want versus what you actually want.
Yeah.
Yeah, there's a lot of bugs like that. So those, yeah, you could never. I don't think you could ever fix that with the programming language. But if you get down to only those, that really would be great.
Yeah, that'd be pretty awesome. So is there only one Rust compiler right now? Yeah.
Yeah, only one that I know of, and
Yeah.
certainly only one major one.
Yeah, and is it written in Rust as well?
Yeah,
Yeah,
makes
okay.
bootstrapping interesting.
Hmm?
It makes bootstrapping it interesting. I heard there's some trouble with the Debian packaging originally over that, because you can't, like, you need a binary of the Rust compiler to the Rust compiler. You can't get back and do it entirely from free software to begin with, because you've got to start off with the binary.
Right.
I mean, the same thing goes for GCC.
Well, yes, yeah. And, except like every every time you install a system, it's gonna like everything almost always comes with a C compiler to begin with. Like it's not like you can have trouble finding binaries for a C compiler.
Yeah.
No, but I get what you mean. Yeah, so that's pretty interesting. So do you know what architectures it supports? The Rust compiler.
Well, it now supports 64-bit RISC-V Linux.
Yeah.
Generally, yeah, the main ones are x86 and all the big platforms, and 4-bit ARM. I think off the top of my head, there's a supported platforms page if you really want to know. In theory, it can support anything that LLVM supports, but in practice, you've still got to get the tests to run it to build, and there's very small amount of information you have to tell Rust about. But all the hard work's in LLVM.
So what was your blog post about?
So that was the gap between it being in LLVM and it actually being useful in Rust, I guess. So
Right.
But yeah, see, you have to put a target specification to the compiler, but that was already done when I started. But then I tried running some of the tests for RISC-V Rust, and they didn't all pass. And a lot of them, it was weird because it wasn't stuff that it wasn't like, oh, here's the test for RISC-V and that doesn't pass. So here's the test for something architecture specific. The bug that I based most of the blog post around was getting errors in the wrong order. And there were so in Rust they test every user facing aspect of the compiler, so including every error you can get. Between versions, the text for that error shouldn't change unless someone's explicitly put that into the test that it changes. So you can't regress back to them. And that includes the order that errors are displayed when passing some erroneous source. So the test I had started with a match expression, which is what's that most like in familiar languages? It takes a pattern. So you could say that I say you have a tuple of, I don't know, a string and a bool. You could then say that, well, if the bool is true and the string is something else in modern things, or you could just capture the string and use that in the body.
Right.
It sort of lets you say, here's a syntactic shape of what I want the thing to look like, and if it looks like this, then match it. So it's sort of like a case expression, but goes a lot further.
Right. Like a regular expression?
So yeah, well, I think a limited regular expression. You can't show as much as a regular expression.
So we're talking about parsing the source files now.
Yeah, well, it's a syntactical structure in Rust, so you can use it. So you could just use it as a case statement and say, oh, well, if it's literally this, but you can also say, yeah, if it starts with this or whatever. So yeah, and you can go a bit into and it's
Oh,
a
so
regular
it's a
expression that can go across.
structure in the language itself.
Yeah,
So
yeah,
it's like, okay, so it's like a case switch, but like more advanced.
yeah. So it's
Right.
like that,
Okay.
but then you can match several things at once and complicated things like starts with this or
Mm.
whatever. So, and that was, so this error message was for saying that you've got one of those and it's matching a few things at once, but there's some parts of it there aren't variables for that. So you have to, in Rust, your expressions have to be, it has to be total, so there isn't an ambiguity in what it's matching.
Mm-hmm.
So it was saying that so say you've got like a three-way tuple and you've only said what one bit is, you can say that you can, as long in Rust you're allowed to have the other two bits just as I don't cares, but you have to
Mm-hmm.
say that I don't cares, otherwise it spots that, hey, you said that you were looking for one type of variable and it's another one.
So like an equals operator, except like if you have a tuple of 3 elements, these two are going to be equal if one of them, if like the first element in both A and B are equal.
Yeah, that's one thing you
Okay.
could do. Yeah.
Right.
So you could say X is one of those tuples. You could say match X, and then I can't remember what the exact the word they use in the language is. But you basically say in the case that X is the thing you want it to be, and the thing you want it to be can have some unknowns in it and can be sort of complicated, then go into this subtree. And the errors were looking for if you didn't quite match, you didn't have variables covering everything in that thing you want to match, or variables or unknowns. To say, you've written your match expression for a 3 tuple, but the thing you're matching is actually a 4 tuple or something. So it comes out with that. So you wouldn't expect that to be at all RISC-V specific. At least I wouldn't. There's nothing in there. It's just.
So hold on, I'm going to interrupt you for a second. So do I understand correctly? The compilation process, the way it works, it translates it to LLVM, as kind of assembly level language, and then from that to architecture specific assembly level.
Yeah.
Okay, so that's pretty interesting. So I mean, just to explain to people who don't know what LLVM is and what it works, how it works is, LLVM is basically it's like an assembly language, except it's supposed to be platform independent, right? So it's like the idea is it's useful for stuff like writing compilers because you can translate stuff to an assembly level, sort of like an assembly level language, which it looks like assembly, but it's platform independent. So that's what LLVM is.
Yeah.
And then, the idea is that because you translate from, let's say, Rust to LLVM assembly, what is it called? Does it have a name? The assembly level?
LLVM intermediate representation.
Right. Okay. So there's no, I thought it was an acronym for it.
IR.
IR. Okay, IR. So let's say you translate Rust to IR. And the idea is that that's going to be, this complicated compilation process, but you only do it once. You only have to implement it once. You don't have to implement it for every specific architecture, because you translate it to this IR language that's architecture independent, and then you have then this process of translation from IR to x86 assembly, or ARM, or RISC-V, which supposedly it's because supposedly will be simpler. That's the assumption, because it's kind of the same level, one assembly language to another assembly language.
Yeah. And so you can just sort of factor different things out. So you can there's lots of compilers that use LLVM as a backend. So it's like Rust, BPF, and Clang. And then if you put an optimization in LLVM, it works for all of them.
Mm. Yeah. So you can
Um,
basically do optimization, or really anything meaty, anything complicated. You can do it. You can do it, between let's say, between Rust and LLVM, or C and LLVM, or, any language and LLVM, and you only have to do it.
yeah,
You only have to implement it once for the architecture.
yeah.
Okay, so where were we? So we're
So,
talking about.
so sort of describing this test that's gives Rust an erroneous source file, tells it to compile it, and then looks at the errors and checks that the errors it comes up with are the same as expected in the test. And it turned out, and as we talked, in the test, it involved sort of matching these variables up. And the only thing that was the only thing that was dependent on Rex 5 was the order that the errors showed up in, which was really weird, because you'd expect something that just at that point all the compiler's really done is looked at your source file and passed it into a tree, and is just sort of looking at the tree to see if it makes any sense, and it's going, oh, it doesn't make sense. So it shouldn't really care what the target is at that point. So I was thinking, it was pretty clear what was going on. So spent a while investigating and reading lots of compiler source and things. As explained in the blog post, it comes down to string interning. So the idea is that if you imagine you've got some source file, and the first thing the compiler does, it turns it into an abstract syntax tree, which is like it has tree-ish shape, where you're so say you had 1 + 1, that would then become, there's a plus operator where the left-hand side is a literal 1 and the right-hand side is a literal 1. So they've got a tree like that. So it wants to turn your entire source into that sort of thing. So if you sort of imagine writing that, you end up with a lot of strings coming up over and over again. So say you have a variable binding, you're going to have the name of the variable once when you're declaring it, and then every time you use the variable, it's going to show up. So you've got the same string over and over again, and it's a short string, and it's the way the compiler's written, the string doesn't get modified. It doesn't swoop in at that point and change your variable name, because that'd be confusing in error messages and stuff. So you've got loads and loads of short, potentially like thousands and thousands of short immutable strings that are used over and over again. So if as it was parsing, every time it saw your variable name, it allocated a new copy of the string, it'd take ages, because you're doing loads and loads of allocations, and it'd use a bit more memory. It'd be no good. So what the idea is that you only allocate those strings once, and then it has a big table of every string that's used in your source, and then when it needs a string, it'll just use an index into that table. Just that.
Well, also you said short strings, but potentially those strings could be long. Like you could have variable names that are like, I don't know if Rust has a limit. I don't know if you ever talk to Java programmers, but there's this you know where I'm going. There's this like weird convention of like some function names in Java are like 60 characters long. So
I suppose at that point it's even worse. So
so I can imagine replacing that with like a reference to a table of names would be a good idea. Okay, but at this point that should be completely architecture independent. Right?
So I was looking into back to the errors about these missing variable bindings. I found the bit of code that was generating that. Those errors were sorted before they were printed out, and they were sorted by the index of that variable name into the big array of all the strings, not by the actual string itself. So it depended on the order in which the variable names were stuck in the big table.
Right.
But still, RISC-V is still passing the same source file, so you'd think that it'd show up at the same order in the table. But some more digging turns out that it doesn't. It's not just things from the source that end up in the big intern string table. It's just to keep the compiler neat and tidy. Every string it's using, it interns and just passes these references around so that everything's the same. which meant that before it passes the source file and it's setting itself up, it was thinking about processor extensions. So on Intel, you might have something like AVX that for doing multiple data per instruction things. In RISC-V, they have loads of these extensions. The idea in RISC-V is to have a really, really small base language and then everything be extensions. That's how you get RISC-V microcontrollers, and they're talking about RISC-V supercomputers, is that it's the same base set, but then there's loads more things tacked on for the supercomputer than there are for the microcontroller.
Mm-hmm.
In RISC-V, the extensions are named letters, just a letter on its own. Like I said, Intel call it something like AVX, and it's sort of obscure. But RISC-V, there's A for atomic instructions, and C for compressed instructions, and D for double precision floating point. The variable names in the test were A, B, C, D, E.
Right.
So what it turned out, what it was doing was it interned the names of the extensions that were active first while the compiler was getting ready. And then when it got to the source file, it then interned the variable names. But of course, A and C were already extensions. They were already in the table with really low indices because they were done first. But B, which is a RISC-V extension, but it isn't used on that target, would end up with a much higher index because it would, the compiler encountered the string much later in its operation. So when the error message was sorted, you'd end up with a different order for these A, B, C, D, E variable names, depending on.
So were the actual variables the same between architectures?
Yeah.
Right. They were just
allocated in a different order.
Right. And why was that?
Because the extensions were named differently on RISC-V. So just RISC-V happened to have extensions that were named the same things as the variables.
So they were named differently. Like, why were they allocated in a different order?
Because the extensions are all processed first, it turns out, and then it looks at the source. So
in both architectures or just in RISC-V?
In all architectures, yeah. But when it got to the source on RISC-V, because it already had extensions named the same thing, it didn't need to reallocate the strings.
Oh, okay. Makes sense, yeah.
So then when they were sorted by the order in which they were allocated, that was why it came out different, just only on RISC-V. So then, yes, it took a lot of investigating, but in the end, it was just a one-line change to sort by the actual string instead of just the index.
Yeah, that's like one of those details where I'm like, I'm kind of happy I'm not doing any programming at the moment. Because like when you think about it, it's just like this one detail, but it's gonna derail, the entire compilation process for that entire architecture. And then, to fix it, it's a one-line change, but to investigate it, probably took you a long time.
Yeah, I can't remember how long it took, but it certainly at least a week.
Yeah, that's pretty much what this job is like.
Yeah.
Seems like it's so strange. Like we as programmers, it seems like the most masochistic job you can have, and yet we enjoy it.
Yeah, it's funny that I think this, for me, particularly on this, there's an intrinsic joy in finding out how the compiler works. I'd always sort of been interested in compilers and things, and just I really like Rust as a language. So digging into the Rust compiler was fun in itself. So I didn't mind that it was this sort of really long, twisty trail to get there.
Do you also get like this sense of satisfaction once you've solved a difficult problem?
Yeah.
Yeah. For me, it's always been about that. Like, we can't really go much into like details of our work when I was at Codethink, because this is gonna go public. So, but like whenever we would like build something from whenever something was like, you come in and something is in a broken state, and you fix it, and then it's better. And I always like that. I
Yeah.
always like that sense of like, oh, it's better now, and now we can, start change something else, and now it's gonna make make it even better, and so on and so forth. So I always enjoyed that part, which kind of made me realize that it's not really like the technical side of it that I'm interested in. It's more just that I like building stuff and like making improving things.
Mm.
You know.
Yeah, it's also it's more general, isn't it? So it isn't
Mm.
programming in particular that you're enjoying, it's engineering or just problem solving.
Engineering, I thought was engineering, but then I thought about it even more, and I think it's more like just building things in general. Whether it's building
Mm.
a business, or even like working out. I've been doing push-ups lately. I'm doing this push-up challenge. So for people who are not familiar with this, I basically posted a picture on social media that said, for every like, I'm going to do 5 push-ups, and it kind of went semi-viral, and now I have to do like over 10,000 push-ups. I've done like 1,500 at the moment, so it's going pretty well. But
Yeah, good.
like even with that, my point is like, even with that, there's this joy of like seeing the counter go up. Um,
Yeah.
yeah, and even if I go back to like my childhood, I always like playing strategy games,
Mm.
or RPGs that had like like those RPGs like Diablo. You would just like go, or like people who play World of Warcraft, which I never played, but like my understanding of it is like you basically walk around like beating the crap out of these like creatures, and it just seems really boring to me. Have you ever played it,
I
World of
haven't played
Warcraft?
World of Warcraft, but I did play EVE Online, which was another massively online multiplayer
Yeah.
thing. It was like World of Warcraft, but with spaceships.
Okay, so basically just like fly around, like beat the shit out of like other
Yeah.
spacecrafts, and like you level up, right?
Yeah. EVE Online is interesting because they have an economy in game that's, if you try and transfer all of the in-game money into real money, it's bigger than some countries,
Hmm.
and it's everything in the game is player made, so you almost get a bit of an economy. So you have a lot of it's interesting on a sort of player to player standpoint of sort of moving yourself up and like basically getting a bigger spaceship, and then there's player alliances controlling territory. It's almost emerging governments forming and things. So it was fun on that point, but I was never very good at it. So for me, it was always about getting a bigger spaceship.
Well, but my point is like you level up, and like even though the process itself is boring, I don't know about Eve Online, but uh, or or the World of Warcraft for that matter, because I never played it. But just the games that I did play. Have you played Titan Quest? That was a game when I was a kid. Well, but anyway, like the idea is that you walk around, you fight like, and you level up, and like the process itself is very boring, but like the satisfaction comes from leveling up, and like I
Yeah.
I could play for like 8 hours a day and like just be like completely, you know just like exhausted after I was done, and yet I would always come back because I have this like, it's the same thing with strategy games. Like I always enjoy like building stuff and like leveling up, so I think, like I have a tendency to workaholism, just working too much. But it's just so fun to like build something from the ground up. Um, anyway.
No, I know what you mean. it's that sort of endorphin rush you get every time you get that little extra thing. It's a lot like addiction, really. You sort of you're stumbling along and everything's sort of rubbish, and then you finally get that level up, and then that's great, and then you want the next one.
Oh yeah.
But it's funny how different people take it different ways, though, because you can see like the same processes at work, sort of just like scrolling through social media feeds or something. I know what you mean. The type of person who wants to build something and maybe wouldn't get as much enjoyment just scrolling through a feed.
Well, so I mean, I think that, so I mean, neurologically, it all comes back to the dopamine pathways. So there's something you do, and then you get a reward for it, and then that propels you to do more of that stuff. So, and I think that's actually universal. I think everyone has, I think that's built into everyone, and like everyone follows that path because that's literally it's literally what drives almost all of our behavior. Like, except for like basic emotions, like, basic instinct like hunger and sex drive and all that stuff. I think like all the like higher level stuff is is largely predicated on the dopamine pathways. Now, so I think that's a universal, but what I think people differ in is, I think people differ in where they get that reward from. So, for some people it can be writing, for other people it can be, something else. Social interactions, some people are more into social interactions, people are more like into solving engineering problems, but I think it's the same mechanism, just manifests itself in different ways. So, and then I also think that people differ in how much patience they can put into that process. So, you can take something that's it's like a low hanging fruit. So scrolling social media, there's not much of a delay between, getting on social media and getting that gratification. So, you scroll maybe for a few minutes, and, it's like a few minutes of boring posts, and then something really interesting pops up. You're like, oh, and that's the reward, right? The same with email. Like most emails are boring, but then, every once in a while you get an email that's interesting, and it's like, so some processes are very there's a very short loop between the reward and the between the boring part and the reward, like, social media. But then I think there's and I guess people differ in how much patience they're willing to put into that. So, social media is on the one end of the spectrum, and the other end would be, something like working out to get a great physique or to lose fat or whatever, because it's this like very slow process, and the reward comes at the end of, months or years.
I'd say working out, at least for me, is a special case, because I agree that's the sort of mechanism for a lot of things. But for working out, it's the doing it that I enjoy, and it's the feeling that I'm progressing towards a goal. The actual goal is never reached, at least for me. It's always a bit further out, because you get like, I'll work out a bit better and get a bit fitter, and then the standards will increase faster than I am.
Sure. But I mean, so basically you hacked the system, right? Because you said, let's say you said you work out for like an hour, and then you feel better at the end of it. So that's your reward. So in a sense, you hack the system because, you get that reward faster. And I actually think that's necessary. And I think it's one of the strategies that people who go after long-term goals employ more successfully than people who are not successful at it, is that they can break. And, there's some research on this as well, that if you set short and specific goals, short, specific, and, attainable on a realistic time scale, then you're going to get, you're more likely to succeed at going after your larger goal. But nevertheless, I still think there's this, predisposition to how much effort people, or how much long-term thinking, even if you're going to break that goal into like smaller goals, people are going to put into that. So like you know running a business, for some things, like for some things it's almost like you have to have faith for years and years to come. Like I don't know, are you familiar with Kierkegaard, the philosopher?
I'm familiar. I haven't read lots of his work.
So like a huge thing for him was that you have to commit to a decision. You basically commit to a decision first, and then you follow through on that decision on the basis of you believe it's going to have the consequences that you want.
Mm,
And a lot of things are like that, I believe. You just have to go, um like you have, if you go after something, like running a company successfully, like Codethink was a small company for most of its existence, right? And then it kind of grew quite rapidly. I don't know. I don't know the history of it that well, but it like it just, it's so fascinating to me, the people that have enough courage to go after something that you're not gonna see any results for like 5 years or 3 years. You're not gonna see any results for years, and you're gonna have people tell you that you're wrong and that you shouldn't be doing this and all this stuff, and yet have the conviction to go ahead with that.
mm. Yeah, yeah. Faith is a good word for it, but I think you do need to be. You need the other. You need to be quite intelligent about it as well,
Mm-hmm.
because you can get to a real disconnect between in the end between your dopamine and the result. Because when you just sort of reason it, it's all reasoned out. You could get to the result and realize it wasn't actually what you were aiming for. So sometimes I'll do that with books. I'll get it in my head that I'll read this book, I'll finally understand everything, or just one more book and I'll finally understand everything. But actually, if I'm really honest with myself, it's almost planning which books I'm going to read
Mm-hmm.
can be as enjoyable as actually finishing the book. Quite a
Mm-hmm.
lot of the time. I mean, there's some books that sometimes a book will just strike me and it'll be incredible. But a lot of the time, it's the distracted thoughts. I'm like, oh, I can read this, and then I can read this, and then I can read this, and then
Mm-hmm.
suddenly I'll finally understand everything, and my life will be perfect after that. That's actually, I mean, it's wrong, but it's quite an enjoyable thought
Mm-hmm.
sometimes.
No, I can definitely relate to that because I do that quite a lot as well. Which is, I always tell people that I'm addicted to reading, and that I should read less. Like every time someone tells me I should read more, I'm like, I should read less, right? Because it's very easy to, like, for me, I would get stuck, and like I would think that I'm gonna get what I want. Well, like you said, like get what I want, like everything will be perfect after I've read those books. And I realized in the reality, I just had to do the things that I wanted to do instead of reading about
Yeah.
whatever I was reading about. Um, but um, yeah, but it's almost like it's the same process involved in this. Like like it's almost like you're leveling up by reading those books.
Mm,
So you have it planned out, like I'm going to read this, and then I'm going to read that, and then I'm going to read this, and then I'm going to read that, and so you read book number one, and you're like, okay, I'm like 1 point out of 10 on the way to reading whatever I want to read, and then you read the next book, it's like I'm 0.2 out of 10, and you feel this like leveling up,
mm,
uh, and that's why I would. So sometimes I would even read books that were boring, like just to finish them. I try not to do that anymore. Like I'm try like one thing that I'm trying to get better at, and I got better at, is being more selective at what I read,
Hmm. How do you
right?
go about that?
Um, well, I mean, I just like I whenever I get like an impulse, I should read this, I just examine it more carefully, and I'm like, do I really want to read this, or is it just like, like basically I rate my excitement for the book. So let's say I want to read a book called Essentialism. That's one of the books that I want to read. So, and in my mind, I go like, what's the level of excitement on the scale from 1 to 10? And if it's less than 9, I'm just not going to read it.
Hmm.
Right. So I only go for like the top 10% of the books that I want to read.
That's quite good, because then you sort of avoid what I was worried about there. I was saying about making sacrifices now for the future. It's like
Mm-hmm.
you can get to like amazing things you can never get to that way, but you can also just sacrifice now for something you didn't even want. So you do need
Mm-hmm.
that step where you, because there's been lots of times I've decided that, well, if I read this book, I'm going to understand, and actually I was just mistaken about the value of the book, and
Mm-hmm.
the sacrifice the long-term goal of having read the book and understood it, but it wasn't as useful as I thought. I mean, there've been other times it's been the opposite as well. But as I said, you need that real assessment where you think, is it, where you sort of judge if is it a 9 out of 10
Mm-hmm.
excitement. If it is, it's going to be worth it. But if not, yeah,
Mm-hmm.
it's a balancing act.
Yeah. And like when you said about sacrificing the present for the future, the fun thing about this is because of the way of because of how your dopamine pathways are structured. If you do it correctly, if you sacrifice the present for the future and you do it correctly, you go for the most exciting things that you want to go for, you're actually not sacrificing the present. I mean, you are in a way because you're going to get better things in the future, but psychologically, you're going to feel 100%
Mm.
happy now because because you're engaged in this process of like going after the goal that you want to go after. So,
Have you read Epicurus?
nope.
Quite interesting. It's a ancient Greek philosopher. He was a hedonist, but not hedonist in the way you'd normally think. So
Mm-hmm.
it's similar to Buddhism, really. He's sort of saying that, well, yeah, okay, you could be a hedonist and then eat all the wonderful food you want right now, or gamble or whatever. But in the end, that isn't going to make you happy in the long term.
Mm-hmm.
Really being a lot more disciplined, and happy with the smaller things and enjoying your work as you do it is how you're actually happy. So it's very similar to what you're saying.
Mm-hmm.
So
Well, I mean, I think that's true. Um, I mean, so there's two things here from what I understand from what you just said, is that one thing is appreciating small things. Um, and so that's one, but the other thing that I'm talking about is picking up activities that are ambitious enough that you don't even don't even look ahead in the future, because even though you are sacrificing the present for the future, you're not like psychologically, you're not looking ahead for the future. You literally just engage in the moment because it's so engaging.
mm,
So, in the past, because I was brought up in a way that my mom was very cautious, like, and very overprotective, and I had it ingrained in me that to do anything, I had to be very, very prepared, and everything is going to be very difficult. So, which is a good thing in a way because it protects you from all kinds of like impulsive behavior. But what I found was, so then I would do stuff like, I would prepare very carefully for everything. And, I would read a lot. Like in the past, I would, like before I got my first job as a software engineer, I spent like I probably spent like a year just learning about stuff. Like after I finished high school, I spent like a year just not having a job, not being involved in any course or anything, just learning on my own. Even though I did have enough skill to get a job, I just felt like I needed that extra preparation. And that process like carried on for pretty much everything I did. I would always like over prepare. Um, but what I found is like I have to go like I have to go and be regulated by my sense of excitement or my
Mm.
sense of meaning. And what I mean by that is because I was reading so much and like I was over preparing so much, I was never happy and um, I was never as engaged as I could be. So after I stopped doing that and I actually started, getting the right mixture of preparation and action, everything changed and like everything became more engaging. Like
Mm.
you don't want things to be so like on the edge that you're gonna be overwhelmed and you're gonna, have a mental breakdown. But on the other hand, you don't want things to be so mellow that you're gonna have a mental breakdown on the other side, like on the side of not having enough action.
Yeah, I know what you mean. It become very boring if you've got everything figured out. I think somebody might have been Alan Watts used the example of chess. So when you get to the point where both players can see who's going to win, the game stops there. You don't then do those
Mm-hmm.
3 moves get to checkmate.
Mm-hmm.
It's just over and you start again because it's only fun while there's that element of unknown. So
Mm-hmm.
you got to prepare enough that the unknown reduces to a manageable level. But if it's all gone, there's no fun left.
Mm-hmm. Well, and also paradoxically, if you don't have enough action, that actually breeds anxiety in a way um, so because if you don't have enough action, you are not exposed to enough things that are scary to you, and you don't build up enough skin in the game. You don't build up enough resistance. You don't build up enough bravery to face those things. So like I'm actually less anxious now that I'm doing things that would be stressful to most people than I was when I was doing less things that would be stress. Like my objective level of stress, if you believe that's a thing, is way higher than most people's now. But like my subjective level, like the how stressed I feel, it's probably the lowest level it's ever been.
Oh, it's
And
fantastic. Yeah.
yeah, it's pretty good. And like my subjective level of stress was actually way higher when my objective level of stress was way lower than most people's,
Mm.
right? Because everything would freak me out then, right? Because I didn't have that skin in the game, bravery. Um, so like little things. Um, like what I was always very OCD, like very everything had to be clean, everything had to be in order, and like I didn't like disruptions to my routine. I didn't like um moving. I mean, like moving home, for example, is always stressful. Like it is to most people, but because I've moved between cities so many times now, it's much less stressful than it ever was,
Yeah.
right? Um so
Yeah. No.
that's kind of interesting.
Yeah. I had the same thing really. At university, I'd really shut myself down and didn't try to avoid the things that I was scared of. And you're right, you just end up scared of more things,
Mm-hmm.
and things that you're avoiding still there, and sometimes you still got to do them. And then since I've been working, it's just like little things. You start either. I find if I go head first for something that's absolutely terrifying, I'm still going to be terrified. There's a point where there's an amount of physiological reaction that's just inconvenient.
Mm-hmm.
You know, like you've still got to get so much sleep and etc. But yeah, if you find like the right little things and then build it up carefully,
Mm-hmm.
quite and a lot of things. It's finding that a lot of things that I thought were scary weren't actually, and that all the people that you think know what they're doing maybe don't.
Yeah, no, well, no one knows what they're doing. There's like one thing you learn about life is that no one knows what they're doing. No one has any idea. Um, but like little things, yes. But sometimes, what's really useful is if you go after something that's like really scary. Um, After a while, I just got excited about things that are really scary. Um, like I don't know, like it's almost like I got addicted to fear.
Yeah, it's I suppose it's like a roller coaster or something.
Yeah, it's something like that. It's like a roller coaster, roller coaster. Yeah.
So you've never jumped too far on the deep end then?
I mean, I definitely have, but I recovered from it.
Okay,
I
that's
mean,
you wouldn't advise any caution then.
I would advise caution. Yeah. I mean,
Okay.
it all depends on the person. Like to someone who's not very cautious, I would advise more caution, and to someone who is very cautious, I would advise less caution.
Yeah.
Right? It's pretty straightforward, but I I think we're probably biologically tuned to more dangerous times than like when you think about it, like we're biologically tuned to more danger than we face in our
Mm.
society, right? Because you don't have to like hunt for food. You don't have like you don't most people don't have to worry that they're gonna starve to death or they're gonna be, you know, attacked by, other tribes that are gonna like kill you and eat you, or predatory animals. You don't have to worry about any of that. So I would say for most people, like for an average person, I would say your impulses are probably on the side of being too cautious,
Mm.
right? Because I mean, like financially, like what's like financially, what's the worst thing that can like what's it's very difficult to end up homeless in a society like ours. Like if you're like there's benefits, financial benefits, like universal credit and all that stuff. If you don't have a job, um, and so you know, and you can always move in with your parents. If your parents don't want to let you in, you can always move in with a friend. If all your friends abandon you, you can go to like a homeless shelter. If the homeless shelter kicks you out, then yes, you're gonna end up on the street, right? But that's like there's like a there's the safety net is more resilient than it's ever been, anytime, any place.
Uh, it's a rough approximation. I don't know enough about it. Um, I've anecdotally, my understanding is it's perhaps harder to access some features of safety net now than compared to maybe in the 90s or the 70s. Um, for example, I used the example benefits and stuff. Now there's a lot of criteria you have to fulfill for benefits. You have to do a lot of paperwork, and I think there's people for whom
Well,
they're
it
in
took me five
enough of a
minutes.
health or psychological crisis that getting all the paperwork done
Mm-hmm.
is challenging. Or even like once you're in the homeless shelter and you don't have a postal address, it's then very hard to claim the benefits to get back onto the wagon because you don't have a postal address.
Mm.
So I think there maybe have been. I mean, I'll give you that to any sort of you zoom out at all, and it's way easier now than 100 years ago or probably 50 years ago.
Yeah, yeah, that's what I meant. Yes.
Yeah.
Well, um, most, like a lot of things that we are scared of now is like social rejection, like psychological issues. But my point is, um, my point is, your impulses are probably more on the cautious side
Oh yeah, yeah.
than than ever.
Mm.
Yeah. Okay. So we've gone for an hour now.
Oh, that was
So
fast.
yeah, it's time passes quickly. So I'm gonna wrap this up. Do you have any if someone wanted to check out your work or find out more about you, do you have any places where they can go?
Gosh, I'm not good at social media. I have GitHub. I'm Tblah, so TBLAH on GitHub, and I think that'll have a link to my GitLab as well.
Okay.
Other than that, I that's
Maybe
probably the best place.
maybe I can link to your blog post.
Yeah,
Yeah, I can put that in the description.
yeah. I published a paper ages ago. If anyone's interested in smart meters, I'll send you a link so that you can.
Mm-hmm. Okay, I'll put that in as well.
Thank
Um, do you know what I've been doing lately? I've been I've been going to like charity shops, picking up books, and I'm selling them on Amazon.
How's that going?
Well, I haven't sold anything yet. So I just sent my first shipment to Amazon like literally a few days ago. So
Mm,
they're gonna do. So I mean, the way it works, it's really cool. Like you ship it off to Amazon warehouses, and from then on they take care of that. They take care of deliveries and returns, customer service. So you're literally just shipping your product off to Amazon, and then it's like money coming into your account. You don't have to do anything, which is pretty cool. Of course, there's fees for everything, um, but I didn't even know that existed. So that's
yeah,
interesting for someone who maybe you have a product you want to sell, um, but you're like a one person gig. You don't really have the capacity to or time to send every order yourself. It's very good for people like that, or people who have full-time jobs. Maybe they want to start like a business on the side.
mm,
um, for people like that, they might be interested in. It's called FBA, Fulfillment by Amazon.
So you'd get all of the Amazon like quick delivery and Prime and
Mm-hmm.
everything like
Yeah,
that.
yeah, yeah.
Yeah, it'd be really
Yeah.
good because it's impossible to replicate that yourself.
Well, it would be quite difficult, yes.
Yeah,
And then you can also like you have a competitive advantage over, because there's two ways you can sell on Amazon. There's what I just described, but there's also the traditional way where you just send
yeah,
everything yourself. But if you do fulfillment by Amazon, then you kind of have a competitive advantage over people who don't, because you get prime delivery and all that stuff. So effectively you can charge higher prices, because prime customers are willing to pay higher premiums
yeah.
for that 1 day delivery. Um, okay. Thank you for being on.
Oh, you're
Um,
welcome. I enjoy listening to the podcast.
thank you. You're probably one of 3 listeners that we have.
One day.
One day, yeah. Apparently, we have a lot of listeners from Australia.
Oh,
For some reason, I looked at the stats, and like Australia is the top country for some
oh,
reason. So, so shout out to all the Australians out there who are listening.
yeah.
All right,
That's good. Thanks, and good luck with your books.
thank you very much. Thanks for being on. Thanks everyone for listening, and I'll see you in the next one.